Hello good day viewers. In this tutorial we are going to find a solution to this interesting geometry problem. We're asked to find the area of the red region in the diagram below. So you can see the diagram right here. We have a square here of 1 unit, and we also have a cycle here with an unknown radius. So how can we find the area of this red region? You can see the region here: 1, 2, 3, 4, and 5. All right, let's get started. First of all, I would like to connect this point and this point together. It is going to give us a diameter. So this is a diameter. All right. Now you can see that we have a right angle triangle right here. And we also have a semicircle here. So now let us pay attention to the cycle. This is a cycle, right? If you find the area of this cycle, then subtract the area of this triangle and area of the semicircle. What you'll be left with will be the area of these two red regions. Now we have other three red regions to find: 1, 2, 3. All right, so let me start with this one. So it means that if you have a cycle, then you subtract the area of this triangle, then also the area of this semicircle. You'll be able to find the area of these two regions. We are done with this. Then we also need to find these three other red regions. So how can we do that? Pay attention to the square. This is a square, right? If you find the area of that square, let me write it down here. Then you subtract the area of this triangle and this semicircle. What you'll be left with will be these three red regions. And we are good to go. So now let us simplify a little bit. If you expand these brackets, you have something like this. This is a cycle. This minus will affect these 2 times inside. This will be a triangle. Then minus a semicircle, because minus will affect the plus sign. We have a semicircle here. Then plus a square. Then this minus will affect these 2 times as well. We have minus a triangle. Then also minus a semicircle. All right, we are trying to find the area of red region. Remember that this will give us minus 2 semicircles, and minus 2 semicircles is like subtracting an entire cycle, because we have a cycle here. So this cycle and these 2 semicircles will cancel definitely. What do we have left? We have a square, right? So the area will be the area of the square. Then we have minus triangle, minus 2 of the area of the triangle. And we are good to go. So now if we are able to find the area of the square and also area of the triangle multiplied by 2, that will give us the total area of that red region. But first of all, I would like to find the radius of the cycle, because without the radius, we will not be able to find the area of the triangle. So now how can we find the area of this triangle? This should be x, this will be x, right? Half base times the height, which is half x times x. That is half x squared. But I would like to start with this one. Remember, the dimension is 1. So area will be 1 squared. That is the area of the square. Minus 2 times area of the triangle is half the base times the height. If you simplify this, you have 1 squared is 1 minus 2 times, this 2 will cancel this 2. So what do we have? We only have x squared here. So once we are able to find the value of x and substitute it here, we are good to go. So how can you do that? Let me recopy the diagram. Let me draw a diagonal line here across this square. So this is a diagonal line. So what will be the length of this diagonal line? According to Pythagoras rule, because this square has 1 by 1 as its side length, so thereby forming a right angle triangle here. So the diagonal of this square will be the hypotenuse. And how can we find it? The hypotenuse will be equal to the square root of what? 1 squared plus 1 squared. That is because this is 1, this is also 1, right? So this will be the square root of 2. Therefore, this diagonal is equivalent to the square root of 2. But I know that we can find it in terms of the radius. Wait and see. Suppose we connect these to the center, because this is the center of the cycle. We also connect these to the other side. Remember that this is tangent to the cycle, therefore this will be a 90 degrees. This will be a 90 degrees. This will be the radius. This is also a radius. Remember that this line is also a radius. So this is another square with dimension r, because all the side lengths will be r units each, right? So what will be the diagonal of this small square? It will be what? The square root of r squared plus another r squared, making 2r squared. And the square root of 2r squared will be what? R times square root of 2. R times square root of 2. So the whole diagonal here will be r plus r root 2. But we already seen that it is equivalent to root 2. So we can relate this to this in order to find the value of r. All right, let's do that here. So we have seen that r plus r root 2 will be equal to root 2. Let's factor out r here. We have r inside, we have 1 plus root 2. And this is equal to root 2. Divide both sides by 1 plus root 2. R will be equal to square root of 2 divided by 1 plus root 2. But I would like to rationalize the bottom by multiplying the top and the bottom by 1 minus root 2. 1 minus root 2. So to the top, root 2 times 1 will give us root 2. Then minus root 2 times root 2 will give us root 4. And square root of 4 is 2. The bottom will be difference of 2 squares. If you multiply this, you take the first term, you square that. You subtract, you take the second term, you also square that. This will be square root of 2 minus 2, right, to the top. To the bottom, we have, this is 1. Square root of 2 squared is 2. 1 minus 2 is negative 1. So finally, this will be, this negative sign will affect these 2 times. So it will be negative root 2 plus 2, or simply 2 minus root 2. So this will be the radius of that cycle. All right, coming back here, remember that this is also a radius from the center to this part of the circumference. This is another radius, which means that this is 90 degrees, right? Therefore, the hypotenuse, which is x, will be r root 2, just like this one. So this x will be r root 2. So now let us find the area of this triangle, because we have seen that the base is what? R root 2. The height will also be r root 2. So the area of red region will be, I think we only need to substitute it here. Why is the formula? Remember, I have obtained 1 minus x squared. And we have seen that x is equal to r root 2, right? So 1 minus x squared is our area, and this is equal to 1 minus x is r root 2 all squared. This is equal to 1 minus r squared times root 2 squared is 2. So what is r squared? Remember, we have just obtained r, so we need to plug it back here. 2 minus root 2. So this is 1 minus 2 minus root 2 all squared, then multiplied by 2. This is equal to 1 minus the whole of this. The first term squared, 2 squared is 4, plus second term squared, that is root 2 squared is 2. Then minus, because of this minus sign, 2 times 2, 4, times this, that is 4 root 2. Don't forget to multiply by 2. This together we have 6, and 6 times 2 will give us 12, right? So we have 1 minus 12 minus, this will be 2 times 4, 8. This is 8 root 2. And if you expand the bracket, the minus sign will affect the 2 times. So we have 1 minus 12 plus 8 root 2. 1 minus 12 is negative 11. So this is negative 11 plus 8 root 2. And hence, this is said to be the area of the red region. But if you want to write it in decimal, you can simplify this, then you subtract 11. Remember the unit squared, because the unit is not given to us. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.